So welcome students. In this question, you're given that in a triangle, the side A is less than or equal to side B is less than or equal to side C. That is, C is the largest side of the triangle. And C square is greater than A square plus B square. In that case, you're asked to prove that the triangle is obtuse. So let us use the cosine formula. Obviously, C is the largest side. So if at all this triangle is obtuse angled, so the obtuse angle will be angle C, because the angle opposite to the largest side is the largest. So C is the largest side. So the angle opposite to C, which is angle C, will be the largest angle. So what is cos C? Cos of angle C by cosine rule is nothing but A square plus B square minus C square by 2AB. But according to the given condition, A square plus B square minus C square is less than 0. That means the numerator is negative. The denominator is obviously positive because these two are lengths. So this implies cos C is negative. This implies C is obtuse. So angle C of this triangle is obtuse, hence this triangle is a obtuse angle triangle. So in this question, we're given that in a triangle ABC, 1 by A plus C plus 1 by B plus C is equal to 3 by A plus B plus C. So if this condition is valid, so you need to prove that angle C of the triangle is 60 degrees. So let us try to simplify this condition. Let us try to see if this condition leads to some information about angle C. So if you take the LCM, you have B plus C plus A plus C divided by A plus C times B plus C is equal to 3 by A plus B plus C. So if you do the cross multiplication, you get A plus B plus C times, you have A plus B plus C plus C. You have A plus B plus C plus another C is equal to 3 times A plus C times B plus C. So this implies you have, if you expand the bracket in this way, A plus B plus C into A plus B plus C. So you have A plus B plus C whole square plus C times A plus B plus C is equal to 3 times, if you multiply these two, you get AB plus BC plus CA plus C square. So this implies, what is A plus B plus C whole square? You have A square plus B square plus C square plus 2AB plus 2BC plus 2CA plus you have an AC again, you have a BC again, you have a C square again is equal to 3AB plus 3BC plus 3CA plus 3C square. So is there any term that is getting cancelled? Let us see. So you have 2BC plus BC, 3BC and 3BC are getting cancelled. Next, 2AC plus AC is 3AC and 3AC gets cancelled. We have 2C square here. So C square and C square is 2C square. So if you cancel it out, you have an extra C square which is remaining here. So you have 2AB here. So if 2AB gets cancelled out, you have an AB here. So effectively you got A square plus B square is equal to C square plus AB. This implies A square plus B square minus C square is equal to AB. And this implies A square plus B square minus C square by AB is equal to 1. Does this formula remind you of some rule? Yes, this looks like cosine rule for angle C. So you have an extra 2 here. So I am multiplying and dividing with 2. This is nothing but cos of C, right? A square plus B square minus C square by 2AB is cos of C. And that is equal to half. This implies C is equal to 60 degrees. Hence the proposition is proved. Thank you. In this question, given that in a triangle ABC, A square, B square and C square are in arithmetic progression. And you need to prove that cot A, cot B and cot C are also in arithmetic progression. So let us first try to analyze what we need to prove. So we need to prove that cot A, cot B, cot C are in AP. So let us try to see what cot A is in terms of A square, B square, C square. Because the given information is in terms of A square, B square, C square. So what is cot A? Cot A is nothing but cos A by sin A, right? That is equal to, what is cos A? B square plus C square minus A square by 2BC into sin A, sin of capital A. So what I do is, I'll multiply and divide this expression with A. So if I have an A in the numerator and an A in the denominator. So this becomes equal to B square plus C square minus A square by 2ABC times A by sin A is nothing but 2R. So this 2 and this 2 gets cancelled. So cot A is effectively capital R by ABC times B square plus C square minus A square. Cot A in terms of ABC is this. So similarly, if you do the same derivation for cot B can be proved as R by ABC using symmetry. So because if you have A, you have a minus A square. So if you have a B, you have A square plus C square minus B square. And cot C will be equal to R by ABC times A square plus B square minus C square. So now what you need to prove is that these three are in AP. So if these three are in AP, you need to effectively prove that these three terms are in AP. But R by ABC is a constant present in all these terms. So from the properties of arithmetic progression, if you prove that these three terms are in AP, it will automatically prove that some constant times these three terms are also in AP. So effectively, your aim now is to prove that these three terms are in AP. So I'll try to do that. I'll start with the given information and try to prove that these things happen. So what I do is I'll start with, given that A square, B square, C square are in AP, this implies 2A square, 2B square, 2C square are also in AP. Because if I uniformly multiply all these terms with a given term, the AP does not change. So this implies I'll subtract A square plus B square plus C square from each of these terms. So 2A square minus of A square plus B square plus C square, comma 2B square minus of A square plus B square plus C square, comma 2C square minus of A square plus B square plus C square are also in AP. So I am subtracting a constant term uniformly. So this implies, what is this? 2A square minus A square is A square minus B square minus C square, comma. What is this? This is minus A square plus B square minus C square, comma. This is minus A square minus B square plus C square are in AP. Now I'll uniformly multiply each of this term with a minus 1. So that implies B square plus C square minus A square, A square plus C square minus B square, A square plus B square minus C square are in AP. So if these are in AP, if you multiply each of this by R by ABC, those are also in AP. Hence cot A, cot B, cot C are in AP. Hence we prove the result. Thank you. So in this question, you're given that in a triangle ABC, angle A is equal to 120 degrees and BC plus CA is equal to 20, AB plus BC is equal to 21. So with these three informations, can you find the length of BC? So let us try to use each of these informations. If you draw the diagram corresponding to this, it looks something like this. Angle A is equal to 120 degrees. BC is nothing but A plus CA is nothing but B is equal to 20. C plus A is equal to 21. You're asked to find the value of A. And angle A is equal to 120. Now, angle A is equal to 120. Let me use this information with respect to cosine rule. So cos A is equal to cos of 120 degrees is equal to B square plus C square minus A square by 2BC. And cos 120 is minus 1 by 2. So that is equal to minus 1 by 2. This 2 and this 2 gets cancelled. So if you cross multiply this, you get b square plus c square minus a square is equal to minus bc. This implies b square plus c square plus bc is equal to a square. So let us keep this information with us. We're asked to find the value of a. So a has been written in terms of b and c. Now from these informations, what is b? B is nothing but 20 minus a. So from this information, b is 20 minus a. And from this information, c is 21 minus a. So can I use these two informations in this expression? So b square plus c square plus bc. So can be written as this implies. So if I have to use this slightly intelligently, I can just substitute b as 20 minus a and c as 21 minus a and expand this. But the better way is, so I can write this as b minus c whole square plus 3bc is equal to a square. So b minus c whole square is b square plus c square minus 2bc plus 3bc is plus bc. Now what is b minus c? If you subtract one from the other, b minus c is equal to 20 minus 21 is minus 1. So b minus c is minus 1. So b minus c whole square is 1. So this completely becomes 1. So 1 plus 3 times b into c. b into c is 20 minus a times 21 minus a is equal to a square. Now if you expand this, you get a quadratic in a. If you solve that quadratic, theoretically you should get the answer for a. Let us do this. So 1 plus 3 times 20 times 21 is 420 minus 21a minus 20a minus 41a plus a square is equal to a square. So this implies 3a square minus a square is 2a square. 3 into 41 minus 123a plus 1260 plus 1 is 1261 is equal to 0. So you can try to factorize this. So 1261 is nothing but 1300 minus 39. That is equal to 13 times 97. So this is 13 times 97 into 2. So effectively you have 26 times 97, and 26 plus 97 is 123. So you can factorize this as 2a square minus 26a minus 97a plus 1261 is equal to 0. This implies 2a times a minus 13 minus 97 times a minus 13 is equal to 0. This implies a is equal to either 13 or 97 by 2. So this implies the value of the side A is equal to either 13 or 97 by 2. That is 48.5. 48.5. So obviously 48.5 is a wrong answer because the sum of two sides is 20. So one side cannot go more than that. So 48.5 has to be discarded. So the answer will be A is equal to 13. BC will be equal to 13. And from this you can get the remaining sides. 20 minus A. So B is equal to 7. And C is equal to 21 minus A is equal to 8. So the sides are 7, 8 and 13. Thank you.